Exploring Pi, Part 3, Squares, Circles, and Hexagons, by Jeff Simpson. A square has 4 sides, and every side is the same length. A regular hexagon has 6 sides, and every side is the same length. An equilateral triangle has 3 sides, and each side is the same length. A circle has no straight sides, but the diameter passes through the center, and the circular edge is called the circumference. You can inscribe a circle inside a square. They touch at 4 points. You can inscribe a hexagon inside a circle. They touch at 6 points. You can inscribe a circle inside a square and a hexagon inside the circle. You can make a Star of David from 2 equilateral triangles. The 2 triangles touch at 6 points. A hexagon is inside the Star of David. It has 6 corner points. You can make a hexagon from 6 equilateral triangles. If every side of each triangle measures 1 unit, such as 1 foot, or 1 meter, or 1 inch, or whatever, then the hexagon is 2 units wide across the middle. There's 1 unit, another 1, put them together, and you have 2 units wide. And the perimeter is 6 units. Because 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6. The ratio, comparing the distance around to the distance across, is 6 to 2. That ratio can be reduced if you divide both numbers by 2. The reduced ratio, comparing the distance around to the distance across, is 3 to 1. Now, if every side of each triangle measures 1/2 of a unit, like 1/2 of a meter, 1/2 of a foot, so on, then the hexagon is 1 unit wide across the middle. And the perimeter is 3 units. You add up all those halves, and you get 3. Comparing the distance around to the distance across, the ratio is 3 to 1. The distance across the middle of this circle is 1 unit. And the distance across the middle of this hexagon is also 1 unit. The distance around the hexagon is 3 units. Is the distance around the circle also 3 units like the hexagon, or is it more than 3 because it sticks out further than the hexagon? The distance across this square is 1 unit. The distance around the square, that's the perimeter, is 4 units. The distance across this circle is 1 unit. The distance around the square is 4 units. Is the distance around the circle also 4 units, the same as the square? Or is it less than 4 because it doesn't stick out as far as the square? The distance around the square is 4 units. The distance around the regular hexagon is 3 units. The circle is between the square and the hexagon, so the distance around the circle must be between 4 and 3, less than 4 units, but more than 3. So the distance across the circle is 1 unit, and the distance around the circle is more than 3 units, but less than 4. What number do you know that is more than 3, but less than 4? If you watch the part 1 and part 2 videos, you're probably thinking, more than 3 but less than 4, it must be 3.14. And you're right. Yes, it's pi, approximately 3 14/100. When the distance across the circle is 1 unit, the distance around the circle is pi, approximately 3.14. When the diameter of the circle is 1 unit, the circumference of the circle is pi, approximately 3 14/100. You might be thinking, but I thought pi was 22/7 or 22 compared to 7. Well, that's right. Pi is 22/7. But let's take a closer look at that. A number over a number, like 22 over 7, tells us we can divide. So let's divide 22 by 7. The quotient is 3.142857 repeating, or you could round that to 3.14, or 3 1/7. So pi is approximately equal to 22/7, which is the same as 3 1/7, same as 3.142857 repeating, same as, rounded off, 3.14. Pi approximately equal to 22/7, 3 1/7, 3.14. When the diameter is 1 unit, the circumference is approximately 3.14, or 3 1/7, same thing. When the diameter is 1 unit, the circumference is 22/7, which is approximately equal to 3.14, or 3 1/7. There's more to learn about pi, but this is enough for now. So that's all for the part 3 video. Thanks for watching, and please share these ideas with other people who can benefit from them.